Hello, good afternoon, sir. This is me, Mukul Rai, and today I am going to give a demo class on this topic, that is the differential equation. So I hope you will like this session. So before we start, what is the differential equation? Let me explain this, why differential equation is important, where we can use this differential equation. Let me explain this. So imagine a hot cup of tea on the table. Now it slowly cools down, and the rate at which it cools down, it totally depends how hot it is compared to its surrounding. And that all this scenario, this real life examples, can be expressed in the form of this equation that is called the differential equation. So we have so many other examples, like you are running on the road, how fast you are moving with the time, that also can be expressed in the form of this differential equation. So before we going deep into that differential equation, we must know what is an equation. So let me explain you what is an equation. So equation is an expression where two or more, like where two expression will be equal to each other. For example, let me write one. So here I have the two expression. This is one expression, this is another expression, and they both of them are equal to each other. So this type of form of this called as an equation. So after this equation, we must know about the dependent and the independent variable. So what is the dependent and independent variable? Let us see. So let me explain this, what is dependent and independent variable, with a very simple equation. Now first I will put the value of x. When the value of x is equals to 1, then I will get the value of y equals to 3. And when the value of x is equals to 2, the value of y will be 4. So look at these things, both the cases. This is case 1, this is case 2. Here I put the value of x is equals to 1, and I got the value of y as 3. Here I put the value of x is equals to 2, and I got the value of y as 4. That means whatever the value I put for the x, I will get the different value of y. That means it is very much clear from here that the value of x is the x is fixed. That is, it is not changing. It is not dependent on any other things. Like you can put any value of x. That is your choice. So I can call this x as a independent variable, because it is not dependent on any other values. It is totally dependent on itself. But here the value of x is dependent on the value of, sorry, here the value of y is dependent on the value of x, because here I put the value of x is equals to 1, I got the value of y as 3. Here I got a value of y when I 4, y as 4 when I put the value of x as 2. So it depends on the value of x. That is why y is a variable, but it is a dependent variable. Dependent variable. So that is the concept of dependent and the independent variable. Now when we sum up all these equations and then dependent and independent variable, we'll get a differential equation. So next is differential equation. So let us discuss now different now let us discuss what is a differential equation. Now when we sum up all this equation and this dependent and independent variable, we will get this differential equation. So differential equation, I must say, I can define like differential equation is an equation containing variable and dependent variable and the independent variable with derivatives of the dependent variable with respect to the independent variable. So it is an equation. If I write, it is an equation with dependent and independent variable with derivatives of with the derivatives of dependent variable with respect to the independent variable. So this is the definition of differential equation. So differential equation is an equation with dependent and independent variable with the derivatives of dependent variable with respect to the independent variables. So let me give an example. This example 1, dy by dx plus y is equals to, let's write 5. Let me write another example, d square y dx square plus 3 dy by dx is equals to, let's write 6. So I got the two equations like this and this. Both are differential equation. So this is first order differential equation, this is second order differential equation. So then what is the order? Then what is the order of differential equation? That we must know. Then if I see, I can see here order is 2, sorry, order is 1, and I can see the order is 2. But what is an order? What is an order? So order means is the highest derivatives in the differential equation. Like the highest derivative is 1 here, that is why the order is 1, and here the highest derivative is 2, that is why the order is 2. Okay, so now the next thing is degree. So next thing is the degree. What is the degree? So degree means the highest power. I can write highest power to the highest order of derivatives after removing radicals. Radicals means actually the root. I can write in bracket root and fraction. That means I must remove these two things. Number one is radicals, that is the root, and the fraction. Okay, so let me give an example to explain degree. Okay, so the highest order is this. So this is the second order differential equation, and the highest power of this second order differential equation is 3. So I must say, I can write degree is 3. So this is very easy to find the degree and the order of the differential equation. So this is how we can identify the degree and the order of the differential equation. So next thing is method of solving. There are many ways to solve a differential equation. I will teach you the simplest way to solve this differential equation, that is called the separating variables. Separating variables. Let me explain this method, how to solve this using this method. Let me write one equation. Dy by dx is equals to x by y. Now look at this equation. So this is dy by dx is equals to x by y. So this is a first order differential equation. Now let us separate the variables. So y dy x dx. So I have separated the variables, y with respect to its y and x with respect to its x. Now next step is to integrate. So integrating the equation, let us say this is equation 1. Integrating the equation 1, we get, so y dy equals to x dx. So after integrating, I will get y squared by 2 is equals to x squared by 2, and we must write some constant. What is c? C is a constant. But why do we need a constant here? Because this differentiation doesn't have any its limit. It doesn't have any limits. So we call this is a indefinite integration. So when you're solving an indefinite integration, we must write some constant. So this is the things after we integrate the equation. So this is the way we can use this separating variable process. Okay, so this is one question, and let me write this question number 2. Let me write the next question, question number 2. Square root of 1 minus x square dy plus square root of 1 minus x square y square dx is equals to 0. If you look at this question looks very tough and difficult to solve. But once you're done with this method of separating the variable and use the proper concept, then you can easily solve this. Let me help you to solve this. Let us divide both the sides, both the terms, by square root of 1, like square root of 1 minus x square and 1 minus y square. Here also we have to divide by 1 minus x square and square root of 1 minus y square, plus here also we have to divide by square root of 1 minus x square and square root of 1 minus y square. Now if I divide this, I can easily cancel this and this and this and this. So I only left with dy by square root of 1 minus y square is plus dx by 1 minus x square is equals to 0. So I hope now it is very easy to solve. Let us integrate this. Before we integrate, let us take this one variable to the another side, that is the right hand side. Okay, so when you take to the right hand side, we must change the sign. So take care about this sign. So this is plus, now it will be minus because you are taking to the right. Okay, now integrating. So integrating will give me, after I integrate, so integration of this, like dy by square root of 1 minus y square is sine inverse of y. So there is a derivative formula so for this integration, and for this also this is sine inverse of x plus c. Be careful while writing this angle. We must write with respect to this only, like if it is y, write y, if it is x, write x. Okay, and then one constant, so c is equals to constant. Okay, so this equation I can write as sine inverse of x plus sine inverse of y is equals to c. So this is the easy and quick method of solving this type of differential equation by using separating variable method. So thank you very much.